Hey guys, I'm back at the laboratory. You already know that gravimetry is the chemical analysis where we measure mass for use in chemical calculations. But what if instead of mass, we measured volume instead? That is the gist of titration or titrimetry. In this video, I'll show you how I can do just that in the laboratory. I will be measuring volume so that I could calculate for the concentration of the analyte in my sample. If you're ready to learn, let's do some experiments. The type of titration that I will be doing today is called a neutralization or an acid-base titration. A neutralization reaction, as a review, is between an acid and a base, where the reactants will form a salt and water. If I start with a solution containing an acid, the pH will be below 7. However, if to this solution I keep adding base, the acid and the base will react. Since acid is used up in the reaction, the more base you add, the higher the pH will be. There will also come a point where there will be more base than acid. In that case, the pH will be above 7. The principle of neutralization titration is that we slowly add an acid to a base or a base to an acid until it reaches molar equivalence. When I say molar equivalence, we reach a point where there is enough acid for enough base. If you can imagine, for the reaction between hydrochloric acid and sodium hydroxide, if there will be enough hydrochloric acid per sodium hydroxide, the pH of that solution would be 7 because there will be no more hydrochloric acid or sodium hydroxide remaining to contribute to the pH of the solution. For us to be able to calculate for molar equivalence, we need accurate values for the volume and the concentration. Volume, as you might imagine, can be accurately measured in the laboratory using special glassware. But how do we make sure that the concentration of our acid or base is exact? We need to use standards. I have here a very non-suspicious container of 0.1 molar sodium hydroxide. I want to use this for my titration, but since I don't know who made this or when this was made, and I do not know the exact concentration, I want to convert this into a standard. So, this video will show you how I will standardize the sodium hydroxide solution.
This is the burette, which is the volumetric glassware I will use for delivering known amounts of volume. It is a TD instrument, and this particular burette has a capacity of 25 ml. I put my sodium hydroxide inside. This burette is one of those auto-fill burettes where you squeeze it to fill the container, and it is calibrated to auto-fill to 0. This makes sense for frequent routine analysis like in production lines. I personally do not like starting at 0, so I pass some solution through the burette first. While the burette itself is filled, that tip might not be. I need to fill this tip with sodium hydroxide by pressing on this button to release solution. I should also be careful that this tip will not have any air bubbles so that my volume readings will be correct. If I look at the meniscus, I think it passed the 2.1 ml mark. Since the last reported digit is the first uncertain digit, I'm going to estimate the second decimal point. I'm recording 2.12 ml in my laboratory notebook. Since I have my base as my titrant, or the solution I'm adding volumetrically, I need to have my acid in an Erlenmeyer flask. I accurately weighed here potassium hydrogen phthalate or KHP. I'm adding some cooled boiled distilled water to dissolve the solid, and I'm mixing it. I boiled the water first to remove carbon dioxide, which makes water acidic. Since I only want my base to react with KHP, I had to remove the carbon dioxide. KHP is a molecule with one acidic hydrogen, so it reacts in a 1:1 mole ratio with my base. KHP is what we would call a primary standard. It has features that allow us to accurately describe how many moles of it there are. By doing this standardization procedure, I'm using my primary standard to also accurately know the moles of my base for a certain volume. This converts my base into what we would consider a secondary standard. After standardization, I could then use the standardized sodium hydroxide to titrate with other samples. Both sodium hydroxide and potassium hydrogen phthalate are colorless, so I wouldn't be able to tell if equivalence has already been reached. I'm adding to my flask 2 drops of phenolphthalein, which is an indicator. Indicators help us by giving us an endpoint of detitration. For example, phenolphthalein is purple at pH 8, so I should stop detitration at the first shade of light pink, because that should correspond somewhat to my equivalence point. During titration, I slowly add my titrant with one hand and make sure that the other hand vigorously shakes my flask. Upon addition of base, you will notice that the solution briefly turns purple. This is the phenolphthalein reacting to the base. I need to be careful, adding titrant dropwise when necessary so that I won't get to a dark purple color. At the end of detitration, the color would be very faint pink, and the solution should sustain this color for at least 30 seconds. I am recording the final volume, and here I am estimating it to be 16.86 ml. To show you what it would look like if I over-titrated, I'm adding one more drop. Notice that the color is really dark, so at this point it's probably already beyond the equivalence point.
Well, that wasn't that hard compared to gravimetry, but it's still pretty hard. Since it's difficult to control the droplets of the titrant or the sodium hydroxide, I had to be very careful to make sure that I didn't over-titrate. If I over-titrated, that already classified as a gross error, and I needed to reject that titration and start over. With the final volume of the sodium hydroxide, I could now subtract the initial value and then get the total volume used of base. Since I know the moles of the acid used, I could now calculate for one trial of the concentration. Again, I need to do this 2 more times so that I could establish reliability. I hope you learned something new today, and I'm so sad that you can't get to experience titration here with me today. But in the future, when you do titrations, I hope you picked up some useful things from this video. I'll see you next time.